Because that's me. Okay, take the dead one.
Miss Wallace is dead.
Miss Wall, there's three right here that need batteries.
Yeah, I don't have any.
Miss Wall, you said.
Do me a favor. Why don't you lift up the ones that you have and do work, put them all on the bottom. That way they're not at the top. All right, so yesterday, we started talking about this reaction, right? Yeah, that's good. Sound good. You two can't be quiet.
I know.
I need you to get up and go back over to your side of the room.
Be quiet.
It's that simple.
No.
Now, if we have this reaction, N2O4, all right, it starts out as colorless. And as it decomposes, it starts to change colors. Now, that's not important for what we talked about yesterday. The important part is, if it only has one arrow and it changes into NO2, this shows that we only have how many types of processes taking place? One. And so, as time marches on and N2O4 decomposes or changes into NO2, what has to happen? NO2 has to do what? Change back into N2O4, or we can never reach equilibrium. So, yes, we did. Now, you do not need to write what's in green here, unless you just don't know that from when we talked about this when we did physical equilibrium. Now, based on yesterday's quizzes, some of you need to write this, okay? Yes, we did. And I'm going to hand those back in a few minutes when we're working. All right? Now, some of us need to write it. Equilibrium is a condition in which the rate of the forward reaction equals the rate of the reverse reaction. Now, when I say the forward reaction, you two need to stop talking too. That doesn't just apply to Betts, Bay, and Salma. And the reverse reaction. Do you know what I mean when I say forward and reverse? Because I'm going to use those terms today. Does everybody know what I mean when I say forward and reverse?
When you go that way, then you
Okay. So when I talk about forward, all right, so this reaction is what we just had, right? Forward, okay, this is forward, and this is reverse. Is everybody okay with that? Yes or no?
Yes.
Okay. So if you don't understand what's in green, you need to write it down.
Yes.
The equilibrium condition is a condition in which the rate of the forward reaction is equal to the rate of the action. And one of the questions I had on a quiz somewhere in the last 3 quizzes, I don't remember which quiz it was on, asked you something. And the question said at equilibrium. And the question had answer choices of it's less than something, it's more than something, or it's equal than something. If the question says you're at equilibrium, what do you have to pick as an answer choice? Is it going to be less than something, more than something, or equal to something if the question says you're at equilibrium? You have to pick that whatever's happening is an equal. Okay? In this case, the forward reaction is equal to the what? Reverse reaction. Now, on the quiz that I'm alluding to, because we were talking about physical equilibrium, I would have had a question that had the rate of evaporation would have equaled the rate of what? Condensation, because we did physical equilibrium. But in this case, we're going to talk about forward reactions and reverse reactions. Now, again, I highlighted it can happen in a physical and a chemical process, because some of you got this question wrong on some quiz in the last 3 quizzes. You told me it could only be physical, or you told me it could only be chemical. It's both chemical and physical processes. Are we caught up? All right, the next one you don't even need. We already talked about the 2 arrows. Everybody good with forward and reverse? If you're not going to remember that, write that down. Forward is this arrow going this way. Reverse is that arrow going that way. Okay? Forward is the arrow going to the right.
Yes.
Reverse is the arrow going to the left. So, in order to be equilibrium, the rate in which you make the forward reaction has to equal the rate in which you have the reverse reaction. Everybody there? Okay. Now, we're going to calculate an equilibrium constant today. That's the other half of the quiz on Monday. An equilibrium constant is going to be K. It does not matter how much of a reactant or product you start with. The amounts don't matter. Equilibrium can be achieved.
Is that general or is that just for that?
It's just for that. So we're going to learn to calculate an equilibrium constant. It's not going to matter how much we start with, what the concentration is. It's going to be irrelevant. We're still going to be able to get equilibrium. We're even going to talk about how to shift equilibrium towards the end of class and on Monday. It's that shifting that's going to create the issues for us. Now, we're going to learn expression between the reactants and the products. All right? We're going to learn how to write one today from scratch. It's very easy. Everybody should be able to do this with ease by the time we leave today. Of course, it does help if you know where the reactants and the products are. Everybody good with that? Because if you don't know, we're in trouble. Where are the reactants? Where are the products? Okay. Because we're getting ready to talk about the steps. There's 3 of them. Everybody caught up? All right. First of all, you're going to love this part. K is unitless. So for those of you who cannot remember to put a unit on K, don't worry, there's no unit. It's one of 2 quantities that we will do. The second one we probably won't get to in chemistry that has no unit. K, and some of you are probably familiar with pH. pH is the other one that has no unit. pH is just a number, K is just a number. K stands for the equilibrium constant. All right? It is not kelvins. Sometimes people go to this wall. How am I going to keep it straight from kelvins? Well, most people don't get it confused because it's going to say K equals and have no unit on it. K that's kelvins is always where. Well, it is at temperature, but it's always where in relation to the number. It's after the number, so people generally don't get it confused. Now, K does not depend on the concentration of the reactants or the products. Remember, I said you could start with any concentration. It's not dependent on the reactants or the products. The only thing K depends on is temperature. Now, the nice thing about being in a first-year chemistry class is the state, in their infinite wisdom, does not want you to know how K changes with temperature. So you're not even going to have to learn the rules of how K changes with temperature. All you have to know is it does change with temperature. So K will always be given in the problem, but will we do anything with it? Will we do anything with it? The answer is no. It will be given, but we're not actually going to do anything with it because it does depend on the temperature. It'll be given, but we're not going to learn how to use it because it's not part of our curriculum. Those of you who plan to, again, pursue something in science, or you want to go into nursing and might have to take 2 semesters of chemistry, you will probably have to do something with this because in college chemistry they will make you. Okay? But our curriculum doesn't want us to do that. So, and given we're at the end of the semester, we're not going to put in some extra right now. All right, everybody caught up? Yes? All right, so how do we find K? Now, I've just got a plain old generic equation up here. Okay? So, I've got little letters and capital letters. So, what do you suppose the little letters stand for?
Coefficient.
Coefficients. What do you suppose the big letters stand for?
The element.
The elements of the compounds. Okay? So, what's the first thing we're going to have to do? Step number 1. We always do products over the reactants. K is always equal to products over the reactants. This is always the missed step in writing K. Universally, on an exam, on a test, it will be the most missed part of the quiz Monday. What do you suppose people do? They switch it up and they put what on top?
Reactants.
Yep. The products have to go on the top. The reactants have to go on the bottom. You can't switch it up. If you do, you get the wrong answer. Products on top, reactants on the bottom. Okay? The brackets stand for concentration. That's all they represent. So whatever concentration they give you, that's what the brackets are shorthand for. Number 2, all coefficients become exponents. So if you have some exponents, you got to make them coefficients. If you don't have any coefficients, you don't have any exponents. So on equations that all have 1s, it makes it easy. You don't have any coefficients to deal with. You don't have any exponents. But if you have 2s or you have 3s, then you got to have squares and you got to have cubes, which is why I said a little while ago, for some of you, this right here would be our biggest obstacle today. Because using the calculator and making sure you got all the squared and the cubes in would create your biggest challenge. All right? And step number 3, only certain states are included. Only include gases and acids. Okay? Solids and liquids are constant. So they're not included. We're going to cancel them out. Okay? So I'm just going to write here solids and liquids cancel out. Solids and liquids cancel out. We're not keeping those. We're only keeping gas and aqueous. We're getting rid of those 2 states. Gas and aqueous stay. Solids and liquids, we're chucking. Sometimes the questions won't give you any concentrations for solids and liquids because they know you're not using them. Sometimes they'll give you the concentrations to throw you off. Okay? So you have to decide, do you need them or do you not need them in those cases? right. Anybody still writing? I'm waiting on. We got it? All right, so let's write one. So let's say that we want to write the equilibrium constant expression for number one. All right, what are my products in number one? Okay, so K equals, first of all right, so my product is O2, right? So O2 goes on top, put it in brackets, over, what's over here is a reactant, O3. All right, so that's step one, products on top of reactants. Step two, my coefficients become what? Exponents. So what exponents on my product? 3. What exponents on my reactant? Do I have any states for step 3 that need to cancel out? So do I have a solid or a liquid in step 3 that I need to cancel out? No. So that's number 1. They all stay. Are you with me? Yay or nay?
Yes.
Okay. So let's do number 2. All right. What are my products, Bryce?
So the answer for K would just like as that.
Just leave it as that. Okay. So number 2. K equals. What are my products? All right. Bracket CaCO3 over, what are my reactants? CaO and CO2. All right. Step 2. Do I have any coefficients I need to put in as my exponents? No. So this time I didn't have any exponents. Step 3. Do I have any solids or liquids I need to mark out? Who do I need to mark out? All right, CaO I heard. And, all right, so those are all gone. So K equals, all right, my numerator you just crossed out. So what do I put in the numerator if you crossed everything out in the numerator? Put a 1 there. Over, what's still in my denominator? CO2. Questions on how to write K? What's wrong, Destiny? You're making serious faces at me back there. Do I need to go back and do it again? Okay.
Do you have to put them in brackets?
Typically, we write them in brackets, yes. Okay. It's either brackets or a P for pressure. And given we don't have any pressures right now, at least you got a phone. All right. So we go back and do number 2 for Destiny. All right. We're going to write K equals. All right. Destiny, what are my products? You can tell me the products, right? Okay, what are the products?
Like, what do you mean?
Can you tell me where the yield arrow is? Okay, so what's on the side of the products on the yield arrow? This is the yield arrow, right?
Oh, okay.
So what's on the product side? Just say it loud enough I can hear you. CaCO3. Say the whole formula. Don't stop at O. It's got a 3 right there. Of course, it would also help my hearing if we're not rattling all that stuff over here. All right, over. What are my reactants? Thank you. CaO. And what's my other product? Or sorry, reactant. CO2. All right, so that's step 1. All right. Step 2. Coefficients become exponents. So, do I have any coefficients to make exponents? No. So, I don't have to do step 2 because I don't have any coefficients this time. All right. Step 3, Tevin Hush. Do I have any solids or liquids that need to cancel out? Look at my states. Do I have any solids or liquids that have to cancel out? Do I have solids? Then they have to cancel out. Okay, so when I look at these, this is a what state? It's got to go. This is a what state? It's got to go. This is a what? A what? It gets to stay. All right, so everything else has to stay. So K equals, what do I put on top if everything went away? So I put 1 over, what do I put down here? CO2. Did you understand how we did that one? Do we need to do that one again too? You understood that one? Okay.
Yeah, I want you to do that other one.
So if we do this one, Salma, what are my products?
Okay, now.
What are my products? Salma, what are my products?
The 03 and 02.
Products.
03. 03.
What is right here?
Use.
These are the products. These are the reactants. So what are my products? O2. What are my reactants?
Okay.
All right. So what are my coefficients when I look here?
3.
What are my reactants coefficients?
2.
Are either of them a solid or a liquid? So I don't mark anything out in that equation. Okay? Are we okay with writing K? Put your phone down, Destiny. All right, write that down. It looks really long. It's not as long as it looks.
All of that.
All of that, that's a sample problem. We're gonna work. You're gonna calculate K. Yes, Hyro, a sample problem. Stop whining. Hyro, I hear you talking again. You're moving too. All right, we got it? All right. So when you're asked to find an equilibrium constant, because you're going to be asked to do this somewhere on that exam, I'll be shocked if you're not. All right? Determine the equilibrium constant. The first thing you need to do is what? What's the first thing you should do? It will be on the benchmark when we do it next week.
Done first.
The first thing I do is what? What did we just learn to do? Write K. So let's write K. All right. So K equals. All right. What has to go on the top? All right. So what are the products? Don't worry about trying to put in the coefficients. Do it step by step. You'll make less mistakes. H2O. And then what else? Cl2. And then what on the bottom? HCl and O2. All right, then go back, put in your coefficients. What's water have? What's chlorine have? What's HCl have? What's oxygen have? It's just a 1. Now, are any of them solids or liquids that we need to mark out? No. All right, now you've written K. All right, we've got K written. Now we can determine K. All we have left to do is the hard part, in my opinion. We have to put the numbers in and get them to come out right in the calculator, which is the hard part for most people. Okay, so what number did they say HCl is? HCl is which of those numbers?
1.2 times 10 to the
All right, so 1.2 times 10 to the negative third, and I have to do what to it?
Square 2.
You got to square it. All right, what number did they say Cl2 is? 5.8 times 10 to the negative 2. And we got to do what to that number? Square it. Yeah.
Why did you square?
Because, see how these have squares on them right there?
Why'd you put the squares like that?
Because they have 2's on them. When we wrote K, coefficients become what? Exponents.
Also, you just passed it over. You just passed it
Mhm.
over.
So when we plug those when we plug in, HCl is this number, or no, water. No water. Water is this number right here. So I'm plugging it in right there.
It's 1.8. You gave me the wrong number.
Yeah, it's 5.8.
How about this?
Okay. Blame the ladies who gave me the wrong number.
Hey, I'm gonna be.
You said HCl. That's
Oh.
what that was right.
Okay. So water is what number?
5.8.
5.8 times 10 to the negative 2. Cl2 is what number? Same number. Times 10 to the negative 2. Do we have it right now?
Yeah.
Okay. Blame me then. All right. So we have those two numbers right. Did that answer your question, Tevin? Okay. So HCl's number then is what? 1.2 times 10 to the what? Negative 3?
Yeah.
All right. And we're going to raise it to what on the bottom?
4.
To the 4. All right. And then I has what number?
3.8 times 10 to the negative
3.8 times 10 to the negative 4. All right, and now the hard part. All right, so when we finish, K is going to be equal to something. Hopefully, we can calculate the right answer. All right. And remember, use your second EE. All right, I'm gonna punch it in again, but see if
Some water.
anybody get that?
I did something wrong.
I may have done something wrong.
I got you to this 10.
No, 'cause I already-
The 10 is what rings the bell for me. That did not. 10 rings the bell.
Yeah, I didn't get that.
That's why I said this did not ring a bell for me. Raised to the 10th rings a bell.
Yeah, I got raised to the 10.
Yep, I did too that time.
Damn, I
Yeah,
got
quit,
quit.
go to me. I didn't think I quit.
Yeah.
That's why I always do it twice. Yep, that's what I got to.
Shells have push it
I can
in.
punch it in.
What?
I can do the long one.
On this, the shells have.
I'll do the first one.
I got this.
Push it in.
And then do
I can't leave it up there if I do that.
Do you use punches?
We wrote it down.
I didn't need it. Don't make that. Don't do it.
When I did that, all right, I have 5.8 E. E. So I said second EE, and then I hit my squared key. So I have -2. Then I hit my squared key. I hit times. I hit 5.8.
Use my notebook too.
I will do it if you want me to, but I gotta take this down. Everybody got one up there?
No.
You can just mind
Oh,
it.
yeah.
I'm good. Tim can get arrow. How to put them both. Right.
And I don't know it, and I don't use brackets.
What do you use? Oh, right.
I didn't use any parentheses.
I don't use it.
You know what, compared to.
I multiply the numerator, I divide by both numbers in the denominator.
It is like,
So you don't really care.
I just don't know if I can get it to show up well enough.
I see.
Can you see what I did? So I multiplied.
Put it in all over again.
Well, I don't have it. All right. So I said 5.8 second EE -2. I squared that. I said times 5.8 second EE -2, and I squared that. I hit equals, and I got my numerator. Okay, divided by 1.2 second EE -3 raised to the 4th, and I hit enter. Okay, so I've divided by the first number on the bottom. Divided by 3.8 second EE -4, enter. I divided by both numbers on the bottom. That's how I did it. I didn't use any parentheses or anything else. So I multiplied the two numbers on top and hit equal, so I got an answer. I don't write that stuff down. I divide by the first number and get an answer. And then I divide by the second number and get an answer. Do you two have it? Are you okay?
I got it now.
So you see the divide by the first number, and then by the second.
Uh-huh. Yeah, but I go ahead and hit equals, so the calculator totals that out. And then I divide by the second number and get
Just
an
got
answer.
it back. I'm back on the thing.
So would you get a different answer? You multiply it, and then the bottom, and then divide it.
You could do it that way. Yes. I'm just not big on keeping track of the two answers or repunching them in. Did you get it, Ira?
I'll get it later.
Get it later. All right, can I take this down?
Let's do it.
We're gonna do another. I was gonna let you practice.
Work hard, play hard, work hard.
All right. What if I ask you to find
Okay.
All right, this time we're going to find the value of n. I've given you the value of k, and we're solving for the value of n. So this one is different. Okay, the value of the equilibrium constant is 6.59 times 10 to the negative third. If ammonia is 1.23 times 10 to the negative fourth, and hydrogen is 2.75 times 10 to the negative sixth, determine N2 given that equation.
Is that temperature relevant?
No, that's why I said temperature is always going to be given because K depends on temperature. It will change to a different value if temperature changes. But that's where our curriculum stops. It doesn't expect you to know how temperature changes. There are rules for how temperature changes, but you don't have to know it. But it'll always be specified in the question.
Yes.
No, I think that's us.
Oh.
Okay.
She's like, no, it's like it does.
It's never necessary.
That was lame. I don't even get it.
So what should we do first? Tell me what we should do first. Find K. All right, but how are we going to find K? What do you mean by find K? Tell me what you're thinking.
Set up the equation.
All right, set up the equation. Set up the equilibrium constant. Now, K equals. All right, so what are the products? Okay, what's on the bottom? Okay. Any coefficients?
Oh, no. No,
What's good?
that was one in the
Just the coefficient.
Yeah, here.
And then they had two, then it would be something.
The product has.
Oh, yeah, no.
No, it does.
What are y'all looking at?
It's not.
What are you
Oh,
talking
no.
about?
What, Destiny?
It's not done.
It's not balanced.
Oh, it's
Oh,
not-
yeah.
I don't know.
So says the wise soul at the back of the room. All right, so how many N's are here? So we need to put a 2 there. And how many H's? So we need a, remember, don't assume if there are no coefficients that it's automatically balanced. All right, if there's a coefficient, yes, the state is balanced for you. But if you see a bunch of 1s, check to make sure it's not balanced. All right, so NH3 has a 2 and H has a 3. All right, are they solids and liquids that need to be canceled out, or are we good to go? Good to go. All right, so the difference this time is I told you in the question, the equilibrium constant is that. So that is the part that makes this question different. I'm telling you that K is 6.59 times 10 to the negative third. Okay? That's what makes this one different. That's the only thing that makes it different. So NH3 is what number now? 1.23 times 10 to the negative fourth. And I need to do what to that number?
Square.
Square it. And then over into, I don't know. And then H2 is 2.75 times 10 to the negative 6. And then I need to do what to it?
Cubic.
Cube it. All right. Now you can go ahead and solve this any way you want. You know, I don't tend to solve it that way first. I tend to do what? I'm going to go ahead and cross multiply. So I'm going to have 6.59 times 10 to the negative third times N2 times 2.75 times 10 to the negative 6 cubed equals 1.23 times 10 to the negative fourth squared. And I need N2 by itself. So how am I going to get N2 by itself? Divide by everything else. So I need 6.59 times 10 to the negative third go away, and 2.75 times 10 to the negative 6 cubed to go away. So that means I got to divide over here by those two things. So 6.59 times 10 to the negative third and 2.75 times 10 to the negative 6 cubed. And then I had a calculator. There it is. What'd you get? I think I need you to say that again.
I said I got 1.103 times 10 to the 11th.
That's what I got too.
I don't want to tell you.
Now, the only difference in this answer, because we're actually looking for N2, is this one is like these things, right? So these have what on them? These have units. These are moles over liters. All right, so we're going to practice just a little.
I already don't want to.
These are short. These are shorter than the ones on the board. These will be quick. They're short. One for Liliana. All right, we're going to do as many as you can, 1 through 5.
Oh, no, I got it.
All right, find me what you can.
well.
Yeah.
Are you gonna pass out the quiz?
Oh, yeah, I will. We do that.
You're not
Still
doing
ready
mine.
for the-
Ooh, what's wrong? I need help.
With?
I don't know if I did it wrong.
With what?
The products on the top line. The products on the top, right? Yeah, and it's all.
Right. Brackets are just notation that means concentration on board. You don't actually have to put brackets in there. But, and means most of it. Just a unit. You don't have to worry about the units. What?
They want you to do this one.
Put that number in for. Put it in for H2. That's number for H2. You put it in for H2. You put that number in. For H2, and that number in for
What did you get for the first one? I got 1 times 10. Oh, no, that's not answer.
Oh, yeah, today, 14.
Where do you go from here? You look at these and look at them. Show the numbers.
Do those and stop sitting there talking. Visual correction.
You got what? Number 1? What are you number 1? The questions, I get, but I don't.
And if you guys have questions on those, I'll answer them when we go over the practice problems. Anybody have a question on what you're working on?
It's not from tricky.
Yeah, Bryce. Where? He got the major pain bus today.
So, what's it
Huh?
Somebody get it.
I know, get up.
Yeah.
Yeah.
Sleep.
This year, yeah.
Let's go talk.
You know, someone-
Good, we're talking that shit talk.
Quiz. Only state that guesses to make you.
No, there's no one trying to just leave those numbers out.
I hear what you said, bro.
Just because they're solid, they're gonna cancel out.
Do we still put the experiments on 1? On 1? It's just 02. Yeah. So it would be the same answer.
Anybody have a question?
I'm not even.
Yes, you are.
I didn't know what you
Just take the
did.
numbers, plug them in the right spot.
On the
Anybody else,
last?
question?
Oh, wait, this.
What?
So,
Right.
what is?
Work.
Better one. Oh, never mind. Yeah. Oh, you just say, you put it in my day.
Yeah, they will always be a scientific notation. some won't be. You don't have to run it at once, I should see. So I'm plugging it in, plugged it in. No, you've already plugged it into your qubit. Okay, so qubits, and then calculate.
This is the hard part.
Okay, so you calculated that one, do the next one. Who else has a question? Yeah.
What's the D equal? I mean,
I don't know, I mean, you do it the way we've been doing it. We're gonna write K, C, L, and then K, C, L, O3, and then this one we're gonna wind up canceling out. All right? Right, now, the thing you've gotta do is, you need to balance these. You've got 3 O's and 2 O's, and then balance. So you're gonna go 3 there, make 6 O's, and 2 there, make 6 O's. And 2 there. So again, this will cancel out, so you're gonna worry about 2. Yeah, so you don't want to keep that. Okay. And don't assume that I balanced the equations, guys, because I did not. No. How do you push that in? You forgot to cube that up in here.
oh,
Oh, hell no. Oh, H negative. It's positive.
That's it.
that's it.
That's it.
Or do we cancel the AP? We always do since we had the.
All right.
No.
You don't have to, I mean, just this, that's the answer. Because these two are solid, so that, and that will cancel out, so you're left with equals that 2 cubed.
Wait, here's one.
Yep.
What about this one that has the
Coffee,
other
bro.
two?
Oh, that's good.
Do we add it?
I wish I could have sleep.
Yeah. Divide one and then divide the one. I'm the one.
Okay, so. Would you give her number four?
Yeah, because it's ion diatomic, so you don't have to worry about that.
I like to.
How about you two up here? Cover. Who else has a question?
I hate the brackets.
Well, first one got 625, then you go for 8.
This two, this is 3 right there, right? So it's 3 O's. There's one right here, right there. Or this is 3 yeah. Is that too low for that, for the O?
Day after Memorial Day. So we've got 2 full weeks, no start teaching exams.
Hey, I heard, hey, oh, I know,
First of year one.
yeah, I heard there's a lot of.
Second,
Oh,
let's make a test.
yeah,
And you do
exam
exam starting that Monday. Our exam is,
flops.
they did it back. Monday is 4th, Tuesday is 3rd, Wednesday is ours. There was a reason they did it, something about seniors not having hardly any on like first period or something. So that's why they did it with 4th first.
Are they gonna do it with, like, the
It would make it all.
Like on a meeting schedule or it is kind
I don't know, because I never go.
I don't remember.
So like they drop the food and then just put it. We never put it by the same there every time.
Yes, automatically cancels out.
Yeah, what do you get for five?
Just
What do you get for five? I mean, we work till 8, so.
Right,
She ate.
cancels out because it's like- That's why I said, most of the time.
Wait, she doesn't
the
like
ones
what
that
it
cancel out,
says.
they're not gonna give you all. Sometimes they'll throw away just to confuse you to see if that means that it's a state review. They'll always give you the states, but you gotta know what it is out of. Solids, yes. Increase in gas. All right, how we coming? We almost there? Yep, hang on.
No, you got.
It's wrong.
No, the back legal one, that's the next topic. We will start like the council, we're doing right.
No, that's kind of fair. Let's see how this is solid.
Oh.
Right up, so the whole-
I know, it was so boring.
Left square, one cube.
And I always get it dry and, I do the
Okay,
right.
equals.
I don't see why there's a point.
No. I did feel
That's how it works out. You get financial.
We're also doing multiplying with the grades.
Well,
It makes it good when they go along.
Yeah, this one.
No, you're putting that such a number. About time.
I won't say yes. A equals.
Write that down. I think that's a good seat, bro.
Nobody's gonna come back.
Bro, I got one for you this week, after that.
So Nancy, go with work. Yeah.
Yeah, right. I got one for you. After that, after
I think she's just like me, everything I'm waiting for. I'm gonna need, well, on my neighbor though.
Oh, yeah. This was a person with me.
How are you? You got a what?
Actually got.
Oh, I wanna wait over there.
The man's telling me.
Feels like.
Well, you get, you put
Looks like your question.
I'm not to put 6.
Did you get?
approach one. I got
That's what I'm.
Okay, now you're right, Jay.
5 times 10 to the negative.
I call it number one sauce.
Well, I thought it was in my head. That's what you're calculating on.
I'm on the vacation.
I'm gonna use this one on one bottle, because I'm using one.
No.
But I take.
Here's the replacement letter.
Oh, yeah, you said, that's my, that's told me that. She wants to leave. Okay, honey, got well, he was inside. I didn't realize that he was on 45 minutes ago. I would love to get copies made during my plan today, so if you call me, I'll need to get that. I just said a couple rates, that's, I didn't need a lot. And that's nice. That's nice.
You know what I'm gonna say?
That was the reason why we got fired. See, they said we got fired. They definitely got fired.
What you got? CO2 is.
Even on the news, they said.
That's what I'm thinking.
Nancy's trying to watch the layout. She told her that we were talking about it in March. Nobody told her we were talking about it in March.
Yours is balanced.
And she was like, no, I'm gonna show you what else happened, because I know you're gonna show me. And you'll be talking shit about me. Yeah, you're right. And she's like, yeah, you're gonna watch it. She's like, yeah, you're right.
All right, let's look at some answers. See what you came up with. Instead of me running around the room like a crazy person, I can probably still do it. Why is there paper up here around me? All right, did it work? I'm beginning to think your calculator challenge. Answer's 1.5. All right, now let's talk about the answers. All right, question 1, 625. Anybody struggling with number 1? Number 2, 1.24 times 10 to the negative 4th. 1.25 times 10 to the negative 4th. What did I say the first time?
1.24.
Oh, 1.25 times 10 to the negative 4th. All right, number 3, 1 times 10 to the negative 14th. We okay on 3? Anybody not okay? 1 times 10 to the negative 14th. All right, number 4, 1.5. Anybody need help with 4? Because a lot of y'all balanced that one wrong from those of you I've walked around helping. Yes, yields 2 CO2. Number 3. All right, you have water, which is a what state, Tevin? It's a liquid, becomes H plus, which is aqueous, and you become OH minus, which is aqueous. So when you write K, you get H plus, which is aqueous, OH, which is aqueous, over H2O is a liquid. This equation is already balanced, so there's no coefficients in it. Water as a liquid cancels out and goes out. Liquids and solids go away. The products go on the top. Solids and liquids cancel.
You should give us homework on this because I like it.
I'm glad you did. Hema.
Just kidding. I'll never do
I'm going back to it, 1.5. K equals, Salma, that's me. So you have 1 times 10 to the negative 8 for hydrogen. and 1 times 10 to the negative 6 for this one. And when you calculate that, you get 1 times 10 to the negative 14th for K. Okay? Now, the biggest mistake in number 4, when I walked around, is that this equation was killing y'all. Now, since we're coming up on the benchmark, and y'all will have to balance somewhere on the test, I might even guess that you're going to see a balancing question on the exam. For God's sakes, there's going to be stuff on there y'all are going to look at and be like, oh my God, what is this? It might be stuff you learned. It might be stuff you've never seen before. You do not want to get a balancing question wrong. So when you look at this, all right, what do you notice about the C's? There's how many C's here?
On that side.
There's how many on this side?
One.
There's how many on that side? Okay, just check. So no matter what you put on this side, you have to put in front of it on this side, right? Okay, so start with the lowest number you can go. Some of you said it was balanced. How many O's are here?
3.
Yeah, there's 1 there and there's 2 there, so you've got 3. So remember what I told you, even numbers are always easier to balance than odd numbers. So the first thing I do is try putting a what here? A 2, because now you have 2 plus 2, which is 4. It's an even number, right? So if you put a 2 here, what do you have to put here? A 2 to balance your C's. Well, if you have 4, 2 plus 2 is 4 O's. O's you have 4 here. 4. It's balanced. Okay, y'all had some really weird combinations out there. Now, from there, K would be CO2 with a 2, CO with a 2, and then O2. Now, most of the mistakes that I corrected were calculator errors, and like Destiny, she had the numbers for CO and CO2 flip-flop. So I suspect if you have an error, it is probably something like that. So CO2 would be 3.0 squared over CO, which is 2.0 squared. And then O2 is 1.5. And you get an answer of 1.5. All right, and the last one, either 0.004 or 4 times 10 to the negative 3rd. Okay, Emma.
But that one, I did different numbers when I balanced it, but then it was still balanced.
Okay, did you get the same answer?
No.
Generally, you have to have these in lowest terms because your exponents are going to make it too big. Okay. Questions? Yes, ma'am. Sure. All right, and number 5, when you're, oops, you forget now we plugged in 1 extra page here. All right, so number 5, you've got, ladies, shut up. When you look at number 5, I asked nicely, I'm tired of asking. K equals, all right, you have Li, which is aqueous, and you have CO3, which is aqueous, and then you have this Li2CO3, which is a solid down here. So what's going to happen to it? It's going to wind up canceling out. All right, let's check our equation. All right, we have Li2CO3 becomes Li plus CO3 negative 2. All right, so when we look at the equation, we have, how many Li's right here, Rebecca? There's 2, so I'm going to put a 2 there. How many CO3s here? 1, and I have how many CO3s there? Just 1. That minus 2 that's at the top doesn't make any difference. That's just an oxidation number. So I need to put a 2 right there, and that can stay a 1 just like that is. This is a solid, so it's going to go away. Okay? So K equals, my Li is 0.2. And of course, I need to square it. And then my CO3 had what number? 0.1. And then that'll just be raised to the first, or I don't have to add an exponent. And then calculate, and you can either just write it as 0.004, or you can write 4 times 10 to the negative 3rd. Either answer is fine. Anybody else? Question on how to calculate K? Anybody? Move over there. Take your stuff. You've been banished to that side of the room. On Monday, stay over there. All right. If I asked you what homogeneous and heterogeneous equilibria were, would you be okay with that?
No.
Write it down then. Homogeneous. What does it mean to be homogeneous? Same state. So, if I look at your worksheet that you have in front of you, can you find a question on your worksheet that has homogeneous equal? So on your worksheet in front of you, can you find a question that has homogeneous equilibrium? Tell me off that phone.
Yeah, the first one, they're all gas.
The first one, they're all gases. All right, so heterogeneous equilibrium. That means all the phases are not the same. So where could you find something that's heterogeneous? The second one, because it has what?
Solid.
Solids and gases. Okay, that's all that means if you see those terms on the exam. I wouldn't think you would, but you might. So now you've been exposed to that. Homogeneous means the same states, and heterogeneous means different states. Everybody okay with that? All right, now we need to talk about what K means, because you might certainly see that on the exam. And I think after we do shifting on Monday, I think we're ready to test. I think we are. I think we're ready for the last test of the quarter, other than the benchmark, or of the year. We'll look at it that way. All right. Oh, I didn't realize.
Test corrections?
I don't think I am. I just don't think I am.
Actually, totally do test corrections on the one. Just.
Yeah, you really should have come and made that up so you could do test corrections. I haven't even graded it. Yours and Emma's were so depressing, I just left them in the stack.
Yeah, you should just like throw it away.
No, you probably earned some points, so I'm not throwing it away, but I just left it for later. Instead, I made out a homework sheet for tonight.
You saw what? On this?
Instead, I made out a homework sheet
this?
tonight. It's actually on, I actually took Monday's quiz and I changed the questions, but it's in the exact same format as the quiz. I just changed all the numbers and the questions. Has the same number of questions, has the same type of questions, has different numbers and different equations.
So you're gonna give us a quiz on that?
I'm going to give it to you for homework, and then you have a different quiz on Monday. And if you can't pass the quiz on Monday, I just don't know what to do for you.
Are you gonna check?
I wasn't planning to,
You should, so we could get a good.
but I thought maybe if I gave you a homework that was identical to the quiz, perhaps we could all do better on the quiz after the disasters I've graded this week.
We should do as a project on our.
I don't know. I'll think about checking the homework, but I thought maybe if I told you the quiz was identical to the homework, other than the questions were different, but they're in the same format, then maybe we do it in hopes to pass the quiz. But I don't really care. I'm an equal opportunity F giver. You know, I'm getting pretty good at it.
Can you check the homework?
I'm not making any promises.
Ah.
All right. So, what does K tell us? All right. K can actually be three things. The first two are on this board. I'm pretty sure the last is on the other board. All right. The first thing K can be. All right. First of all, lots of people do not know what this means. Does anybody know what that means? Here, let me put a blind in or y'all all be right not listening to me in a minute. So let me put that there. Does anybody know what that means?
Is
Oh, it means,
greater than one.
it's like.
Okay.
Right?
All right, it is greater than one, but if I put two greater than signs there, what do you think I'm trying to say?
It's even greater.
Okay, it's okay. So K is much greater than 1. Okay, so I don't mean just like 5. I don't even mean like 10. All right, K is much greater than 1, which means the forward reaction is favored. Let me say it now. Okay, I will say it. The forward reaction is favored. Lots of products are produced. Now, if lots of products are produced, what does that mean? You don't have much of. You don't have many reactants, which means the equilibrium lies to the right. So in the reaction, you have lots of products, very little reactants. The equilibrium lies to the right. Now, the opposite of that would be what? Would be the opposite of that. The reverse, okay? So the reverse would be what? All right, much less than 1. All right, so this would be this one. K is much less than 1. Okay, K is much less than 1. That means the reverse reaction is favored. If the reverse reaction is favored, you have lots of reactants. Very little products are made. And the equilibrium to the left. Are you caught up with me? All right. Now, the one that I did not put up here. K can be. All right, that is not working for me. K can be approximately equal to 1. All right, that means approximately equal to 1. Now, if it's approximately equal to 1, what do you suppose that means?
They'll almost be.
Almost equal amounts of what?
Reactions and
Almost equal amounts of reactants and products. Okay, if K is approximately equal to 1, you have almost equal amounts of reactants and products.
Leave your folder in your car.
All right, everybody caught up? All right, let me see what happened, but I suspect I'm going to change that. Yeah, I don't like it. All right. All right, suppose we have a reaction. N2 plus 3H2 goes to 2NH3, and we have a K that's equal to 258. All right. and you're asked what is mostly produced or in the container. Okay? Now, what is mostly produced or what is in your container? Well, your equilibrium constant tells you this. What can you tell me about our K? Is our K much greater than 1, much less than 1, or approximately equal to 1? All right. Is it much greater than, much less than, or approximately equal to 1? What can you tell me, Tevin? All right. So if it's much greater than, what does that say to us if K is much greater than 1? It's going to lie to the right, okay? So if it lies to the right, that means we have mostly whatever's on the right side. So what's mostly on the right side of this reaction? What are we going to have in the container? Okay, we have mostly products or NH3. Exactly. You have mostly products or NH3. You can say it either way. With me? Then we're going to do another one. All right.
Oh
No?
my God.
What? I can tell.
It's cold over here.
Huh?
It's cold over here.
I'm so sorry. You could have stayed over there, but you couldn't be quiet. So now you've been banished. Bring a coat Monday. All right.
You shall not pass.
All right. What is produced or mostly in the container? Give them that.
It's yeah, approximately equal, right?
Salma, you're going to be the next one banished. To the outer reaches of beyond back there, past Sarah Ellie.
I can't see right there.
Then you need to be quiet.
Glasses right now.
You wearing whose glasses?
Mine.
Oh, they're your old ones?
Yeah.
Okay, then be quiet.
Because also will it still be on the right?
My eyes are not worse.
So the question is this much greater than 1, much less than 1, or is it approximately equal to 1? All right, I would argue that K is approximately equal to 1. That's not much less than 1. 0.1 is pretty close to 1. So if it's approximately equal to 1, what do we know?
It's still to the right. I mean,
It's not to the right and it's not to the
I
left.
have the same number.
All right, you have almost equal amounts. So if you have almost equal amounts, 2, you have I2, and you have HI. You have all 3 of those things in almost equal amounts inside of the container. Okay? Yes.
So none of this will be possible if like a solid liquid is present.
Well, they could be present, but their concentrations would be constant. They wouldn't change. Yes. I would not try to trip you up by asking you about that. That is correct.
I feel like
I would not do that to you. I'm vicious, not that vicious. All right, everybody there? You're talking from the other side of the room. The next place you go is out the door. All right, let's talk Le Chatelier. All right? You said Le Chatelier review, because Sherman didn't know that. Yeah, I told you. No, that'd be almost as picky as gas laws. Although at least that might be part of the curriculum. The stuff they're asking you about's not even part of the curriculum.
Get this. You will not need to calculate. Excuse me, it's chemistry.
Well, the one we did only had to multiply and divide a whole number.
I'm going. Something's not right. But that's not my call.
Okay. Okay. Where do you have to take it at? Okay. How far away? Early in the morning or midday? That's not bad. Not bad. All right. So Le Chatelier, we've already done this. So this should be reviewed. Okay. So for those of you who didn't get him the first time, we're going to try again. All right. We did Le Chatelier with evaporation and condensation. We did him by altering the temperature in a closed system. All right, so we're going to review that with this definition. I'm not going to talk about chemical equilibrium in 5 minutes. All right, we're just going to talk about some review with Le Chatelier here. So write it down and we're going to see what you remember. Hopefully I'll be pleasantly surprised.
You know it's too well for that as well.
Huh?
You know it's too well to get your hopes up like that.
Well, some days y'all surprise me, so I'm hoping for today to be a surprise. Tell me what 2 factors can affect evaporation. Temperature's good. See, there we go. We got one.
Surface area.
He said,
Very good.
Surface area disappointed.
Temperature and surface area. See, that was good. I'm not terribly disappointed. All right. What's one factor that affects condensation? That's today's all day. That's good. All right. So, with Le Chatelier, all right, we have a system. It's at equilibrium. Le Chatelier says if we come in and disturb the equilibrium, it's going to try to get back to equilibrium. Okay? So, let's say we increase the temperature on the system. What's going to happen to the water molecules in the system? They're going to move faster. It's going to cause the water to do what? Evaporate faster. Very good. So if it evaporates faster, what do we make more of? More what? We cannot condense faster yet. All right, we make more what? More vapor or more gas. All right? If we make more vapor or more gas, we're going to do what now? We're going to condense faster. So if we make more vapor or more gas, what's going to happen to our amount of water at the bottom of the container? We're going to have more of it or less of it? Less of it. Okay? Now, going back to a quiz question we had, I forget on one of the quizzes, it was on the homework too. All right? I asked you something. Whoops, that's not what I wanted. I needed this page. All right? Let me see if I can find it real quick because I've got a minute or so. It was on the one that was state.
Right.
You might as well teach them that day.
Yep, it was on. I got it right here. All right, listen to me. All right? We had water. All right? It said there is no vapor above the liquid. Okay? And I want you to listen to the choices. All right? Because y'all messed this up on the quiz. If the concentration of vapor above the liquid is 0, all right? There's no vapor. No, I just want you to listen and tell me which answer choice is true.
Which quiz?
Okay. No condensation can occur. the rate, it was on this page of the homework sheet. The rate of evaporation is high. The rate of condensation is high. And no further evaporation can occur. All right, so which answer choice is correct? No condensation can occur. The rate of evaporation is high. The rate of condensation is high. And no further evaporation can occur.
A.
Hey, you cannot be condensing. Why can we not condense?
There's no vapor.
There's no vapor. When we did this on the quiz, over half the class got that wrong. You can't condense because there's no what? There's no vapor. And I can share that because the people who are not here don't get this quiz. They get a different. Now, homework. Your homework, again, is a replica of the quiz, except the questions have different numbers, different equations. Format is the same. Laid out the same number question. All I did was change the actual equation and the actual number. I don't know what else to do, y'all. Help me. This is what the quiz looks like. In its entirety. Except that the equations and the numbers are different. It's the only difference. There's Liliana back there, don't forget it. Make sure everybody's got one. Everybody get a homework paper. I don't want to hear I didn't know what the quiz